Hello and welcome again to the future. The future is here and now inside Playground, and this is the second episode. The Playground is in the Bay Area of California. Remember, the Playground is a creation of a small team of hands-on billionaires who are helping youngsters turn their great ideas into reality. The Playground funds these new ideas, helps them by giving access to a team of some 50 engineers, data scientists, and deep learning professionals. So each team gets both intellectual and financial support to make their dreams come true. To be clearer, let's go for a quick look back and take some excerpts from my friend Ajay Madhok of what the Playground is all about. What is it about Playground? What makes it tick and what makes it different?
I think they've changed the game, the business of innovation. And when we were growing up, capital was really very scarce and there was abundant talent. So you could do Xerox PARC, you could do an AT&T Bell Lab, right?
But to raise money was tough.
Money was tough, right? Today it has flipped. There is plenty of capital, at least here in the Silicon Valley,
right.
But talent has become extremely scarce. So under those circumstances, how do you innovate? Scale it, reliably, repeatedly, etc. So what Playground brings to the table is human capital and financial capital under one roof. Expertise, talent, and capital working together.
Also, let's just have a quick recap on some exciting ideas that one of the founders, Peter Barrett, known as the Magician, talked to us about. The kind of areas that you're working on, the borderline of improbability and impossibility, what are those?
Well, so we're looking at things like next generation computing, things like robotics, things like the replacement for classical computing and the advent of quantum computers, which will be revolutionary.
Quantum computing. Give me an example of what you're trying to achieve with quantum computing.
With a quantum machine, an engineer can create fertilizer at room temperature the way that biology does. We don't know how
replicate biology, which is one of the most complex natural forms of transformation, right?
And we'll also be able to engineer catalysts and materials that go well beyond what nature does, right? We don't understand how photosynthesis works. We don't understand the mechanism of at the core of photosynthesis. And we could design a process which does the same thing, which is enormously more efficient. We could have buildings that literally sublime out of thin air. Trees do it. Trees are made of air, right? There's no reason why we can't grow buildings the way nature grows trees.
Grow a building.
So, there is carbon in the air, there's all the materials in the air required to build a building. You can imagine with the right catalysts and the right material science, having a nanotube building grow out of literally thin air.
Wow, that is mind-blowing. And you also mentioned you're working on optical computing. What do you mean by that?
That's correct. So there's one of the limitations of computing today is to move electrons around inside silicon takes enormous amount of power and generates enormous amount of heat. Photons are much easier to move around. They're potentially much lower power, and you could do computation at a huge scale, which physically isn't possible with electrons and silicon. So we have a company that's building a neural network accelerator, which is entirely doing the heavy lifting in optics, and can be many times faster than its electronic equivalent. I've heard one of the CEOs here say that he believes that the computing revolution hasn't happened yet. I believe that. I also believe the Industrial Revolution hasn't really happened yet either.
For another mind-blowing experience, I talked to a founder who is also the heart and soul of the Playground, Bruce Leak. The conventional world may call him the Chief Operating Officer or the COO, but in the Playground, he calls himself the groundskeeper. Well, thank you very much, Bruce, for joining us. I know you're slightly busy at times, right?
More than we like. Yes.
More than you like. But
always a privilege, though, to speak with you.
no, it's wonderful, and I find this probably the most inspiring place I've been to anywhere. And that's saying maybe not much, but I love it. And it's your brainchild along with the team. God bless you. And what made you think of it, and what's the objective behind it?
Well, you know, I think I really appreciate the compliments. When the four of us got together to found Playground, it was really about thinking about how could we give back to the next generation of entrepreneurs. You know, the four of us have been through more than a dozen startups over the last 30 years, and we've really had a great experience. And we want to make sure that the next generation kind of has all the tools and the capabilities to not make the same mistakes we've made when we were young. And that we can participate in their journeys and enjoy the ride.
And then learn from them as well.
That they're all going on. And hopefully we can all make new mistakes instead of the same
mistakes will always happen. Now they call, there's a lovely word for it, pivot, right? That's actually a mistake.
Pivot is a large adjustment maybe to a mistake.
Yes.
But
so you've got to pivot all the time. For youngsters who are watching this, there will be occasions where you will have to change course, there will be setbacks, etc. Right?
Things never go as you expect. And that's why, you know, and that's why fundamentally we invest in great people who want to go change the world. And how they actually affect that change, no one's exactly sure. They've got an idea today, and they're going to follow that idea as far as it can go and maybe bounce off that wall and correct into another direction. We just want to make sure that at the playground here we have everything they need to make them as successful as possible. And so, you know, we think of ourselves as a startup. There are a lot of old, large venture capitalists here in Silicon Valley, you know, huge businesses that have been very successful over time. And we're a startup. And so we need to do things differently. We need to be able to move faster. We need to be able to, you know, be more creative. And we need to learn from our own mistakes. And so at the playground, we want to make sure we have everything a startup needs. So beyond just, you know, money, we want to make sure they have a great environment. We want to make sure they have all the tools they need, you know, technical support.
You give them a huge amount of technical support as well. You have a team that really guides all these youngsters, right?
Well, I think having, you know, mentors and having, you know, seasoned technical professionals help them, once again, not make mistakes that have been made before and points them in the right direction so that they can focus on the core differentiation for their business. And of course, you know, beyond technology, I mean, you also need food. And here we are in the cafeteria.
And the music, which we've just lowered, but it's my music, 60s. That's the best sign.
I think so. You know,
You're a well brought up child.
It's proven music. We wouldn't want to experiment on the environment. But engineers love food, and we have more than a dozen companies here, and they collaborate over lunch, over breakfast, over dinner, talking about, you know, partners that work well, you know, lawyers that might be added value, advisors, and also just hiring great talent.
And since you were saying earlier that you don't hire competing any two, so they can all exchange
our
ideas.
investments are always in companies that don't compete with each other.
So there's no worry about that.
And because we want to be able to fully support each one of them, and you know, you love all your children the most, of course. And so you don't want to have children that are going to compete in the marketplace.
And then won't talk to each other and won't sit at the same table.
Yeah, exactly. And so we want them all, they're all at different stages, and they're all in different industries.
So you've done some thinking before you started this?
A little bit. We just want to create an environment that really works.
Wonderful.
And there's no place in Silicon Valley where startups can come together and you know that they've got each other's back and kind of live the dream of creating the future.
Right. And you know, I walk past all these amazing tech. I just wanted to know, what is this? Why do you have
This is one of our companies.
Okay.
Company called Right Hand Robotics, and actually these buttons were done by one of our technical staff to make it so that you can operate this this robotic demo without being inside the secure operations room. And unfortunately, the green isn't a perfect green, but you know, it's still a
Talk
good
about
choice.
perfectionism.
Yes.
Okay. So, you press that, I got it started.
Yeah. So this is a company called Right Hand Robotics, and they create a robotic hand. They call it the right hand for the right job. And it focuses on a machine learning to understand how to pick up a lot of different devices and how to do it quickly and across a large range of devices, products.
Fascinating.
And
I love this, and you just press that and it stops.
you press the red button and it's done, and the green button and it'll start, and now it's going to have to take a little scan of the space to see
Oh,
what's
it's
there.
scanning it right now.
Yep,
Okay.
and then it should start.
Okay, wow.
It's having trouble with that purse.
It noticed there was one more there.
It has
Wow.
to finish its job before it can move on to the next one.
I
Yep.
see. Wow, that's unlike me. I'll move on before. Now, talking about food, I think you've done one terrible thing.
What's that?
May I complain that where all the lovely dessert is, you can't do it quietly.
That's true.
This is really unfair on.
It was a little devious of our engineers. And,
Look at this.
you know, basically,
Let's just move back a bit.
what they found is...
So that's it. So if you're going to have dessert here, what happens?
You have to walk up to get your dessert, and everybody in the room gets to see you.
Oh, so you're
Sneak up
binging today.
and
Right?
get your dessert. And while you're here, you can play with these little pixels on the screen. You can push them around.
Wow.
It's rare that you get to see physical pixels. I've actually spent a lot of
Yeah,
time
yeah,
with
yeah,
video in
exactly.
my life
Of
around
course.
QuickTime and
Yeah,
and
you
around
created
Color Quick Draw.
QuickTime.
And you know, having physical pixels move around, and
It's
actually,
just-
as you said, you get to hear the video as it
Yeah,
plays.
it's lovely, lovely.
And it has a kind of a soothing,
Yes.
you know, musical sound to it. You know, brings you straight to the frozen yogurt machine.
It gets worse
It's a
and worse.
new addition.
All right. Wow, lovely. I must try that later.
But let's go take a look at the shop
Yeah,
where
come,
we do a lot of
come.
rapid prototyping and help some of our teams.
But what do we have this young...
This is one of our prototypes.
No wonder you call it a playground. This is what
and,
you do for your life. I want your life.
We play hard.
So this is an electric conversion of a go-kart, and you know, right
electric,
now we
okay.
have an operator. It's incredibly powerful, which is
This
probably
is-
a mistake for having it inside.
Ooh, ooh.
But actually,
Wow.
it does have a purpose, which is every year we have summer interns come to the playground. And last year they created a robot that would go make coffee and bring it to your desk.
Wow.
A very important feature
Yes,
for
yes.
engineers. And this year,
Wow, that's amazing.
this year the plan is to have the summer interns make these go-karts drive autonomously. Because, you know, it's hard to get reliable help like, you know,
I mean, if I got into it, I'd go straight
George
through the
there.
glass. And so would you, I guess.
Sure. So let's take a quick look. So we'll start here in actually
okay.
the quiet side. It's not too quiet, but this is more the self-serve
So that
corner.
electric go-kart is also a startup?
No, it's just a intern project for our
Intern
summer
project.
interns.
Okay. Wow.
So it's really more of a technology demonstration.
Right, right.
And so in here actually is where we have a lot of 3D printers that our portfolio companies can use
3D printers,
to build
okay.
prototypes. These are fairly standard ABS kind of industrial 3D printers. There's somebody's printing something over here on this one.
Right, right.
This other printer is actually one of my favorites though, because it's essentially an inkjet printer that uses liquid polymers to print plastics or rubber, and then a UV light to cure them. But because it's inkjet, it can mix different polymers, so it can mix rubber along with plastic in the same print.
Wow.
And so you can. So here it is mixed, you know, with a rubber section connected to a hard plastic section.
But you can mix it.
But you can actually mix them
all
together.
these
so
textures.
So you can get different hardnesses of rubber. And so if you're making a product with a button, you can decide what you want that button to feel like.
Wow.
Or if you're doing a prototype of a hand, you can actually print the bones in hard plastic. But you can put the joints in rubber, and you can put a skin on it that has a feel to it.
Wow.
All in a single print without trying to change, you know, from one printer to another printer for technology.
Wow, that is lovely.
It's pretty exciting stuff.
Very exciting, that.
We'll move on through to the next room, which is the main shop, where we do a lot more of the mechanical prototyping. And George, who you've already met, helps run the shop and operate all the equipment for...
He's the person I want his life, right?
Yes, he has a good job. Unfortunately, he does have to do the bidding of the portfolio companies.
Okay.
And so if they need something made,
Sometimes he has to work.
he has to make it. But generally, he can decide how he wants to go about doing it.
All right.
Sometimes he goes about doing that by using his 1950s bandsaw, which we
wow.
bought for, you know, basically $1 per pound. Unfortunately, it cost more to ship it than it did to buy it.
I can imagine.
But it has.
So this is 1950s.
It
you
is.
said. Nostalgia.
And then the latest table saw that has what's it called? Finger stop?
So it has a capacitive touch sensor. So if I were to, I don't know if the indicators are on there, but if I touch the blade, it will detect a changing capacitance on the blade. And if you do not disable an interlock, what it does is it will sense if any skin or metal, or in this case, this was metal, so this was an accident, but it will throw a brake cartridge into into the blade and stop the entire system. So
so if you could touch that with your finger, it'll instantaneously stop the blade before you get more than a finger prick.
I'm not going to test that.
The CEO of the company did on
really?
on live TV.
Brave guy.
Got a small scratch.
He did.
Yeah.
But small scratch from something that powerful is not bad.
It saves a lot of fingers.
Wow, that is amazing.
Technology. Yes. Amazing.
Yeah. Technology and safety.
Yeah. So at Playground we spent a lot of time with robotics. So you saw the go-kart that's going to become automated. We also have the Robotic Dog here. I believe this is the only Boston Dynamics dog that's escaped captivity.
It's quite frightening, actually, that guy.
Once in a while, he goes and plays in the parking lot with some of the real dogs. He's gotten a little more cranky over time. I think maybe it's arthritis, but he's got a little more of an attitude than he used to.
Okay, wow.
This is one of our favorite toys at the playground. It actually
there's a print to be able to.
That is awesome. It's a 3D metal printer. Please take a look inside at the.
Wow! So it's printing that out as we speak. It's printing.
It's already done printing. That was
printed. That's the finished version, but it did that.
It did print that, and so
process.
Okay.
Basically, it prints. It takes a layer of metal powder and spreads it across the center, and then a laser scans out the pattern that you're making, so that basically that powder melts into the pattern. And then it goes down a layer and puts another layer of powder on, and so it's just it's basically scanning with a laser every layer.
Right.
And so we're printing something like this.
What?
Out of titanium, which is the metal powder that's in there right now. So it's very light. And the amazing thing about titanium is it has a bouncing property to it. Unfortunately, this one isn't a uniform.
It's gone under.
We lost it underneath there.
Oh, this moves. Okay.
You gotta want to bounce one of those. Here he is. He's caught under the wheel. And so this one is non-uniform, so when you bounce it, you don't know exactly where it's going to go. Good catch. Right. Try it one more time. Yeah, see, it's just like that. We'll do the last one.
Beautiful.
You're doing well.
It's good for practicing, actually, for cricket.
And it makes a nice sound.
Yeah,
we also have some more uniform ones like this. Feel that one. So
that's
it's made out of titanium
ball.
So it's actually a super ball.
This is predictable.
Yeah.
Wow.
And one of the things we learned when we were using this technology, this is a commercial product that we use to help prototype things for our portfolio companies. One of the things we learned in doing that is that in order to print this ball, it needed to use all this support material to hold it onto the platform while it was printing it. And unfortunately, since you're using titanium powder, the support material is also out of titanium. Okay. And so it's kind of hard and expensive to remove. It takes time and money and people. It also prevents you from being able to print certain objects. And in doing so, we researched this field kind of extensively. We found a company that we later invested in called Velo 3D. And that company is able to print this ball without any support, essentially using the same powder technology. And because of that, you save all that material that gets thrown away, but you save a lot of time and electricity as well. But on top of that, since the ball doesn't have to be mounted to the metal platform, not only can you just print the number of balls that you can print on the platform, but you can print them up in space as well.
Okay, wow.
And so you can get an order of magnitude more things printed at one time.
So to get from here to there was just a brilliant algorithm or something?
Well, basically they realized that the support material really isn't fundamentally supporting this. It's not, the powder can support it. What it was doing is preventing the metal from expanding, from warping, because as you're making it up from the bottom, getting it to close, you can't hold on to it. So what they do is they would nail it down to the bottom here to prevent it from warping. And what this new company does is they model all the stresses that are on the metal from a design point of view before they even start printing it.
That's brilliant.
And then they counteract those stresses as part of the laser process across multiple layers. And so they can actually know where the stresses are and where it's going to want to warp, and then they prevent it from warping.
They've already modeled the whole thing.
They've already modeled the whole thing before they make it.
Brilliant. Brilliant.
And so
they got a patent on that?
They do. And
I bet they do.
They have their beta units out in the world right now, and by the end of the year they'll be shipping new units. So people can create things that weren't possible before. So for example, if you needed to print something that had an enclosed housing, like a pump or something, you wouldn't be able to get the support material out of that middle because there's no access to it. So you wouldn't be able to print that thing with traditional 3D metal printers. And with this one you can. You can just print products that weren't possible before.
Wow.
They call them grails. You know, holy grails that weren't possible before. And so that's an example of additive metal manufacturing, where here's an example of actually subtractive metal manufacturing. This is a 3-axis mill that runs with an ethanol coolant. You can see a little bit of vapor right around the metal tip there. It's spraying alcohol on it in order to chill it so it doesn't get too hot. And that allows this system to run cool, but without any liquids in the way. And so things come off clean. And we can use a vacuum table to hold down the material we're cutting because the vacuum holes don't get sucked up by coolant. And of course we saw the right-hand robotics earlier. Here's some other examples of things that have come off the 3-axis mill. So for example, a drone mold comes off there clean. See how smooth that's just a block of aluminum that's been milled.
So this was done on that. And this is a drone mold, I can see that.
And then similarly, we do a lot of sensors, and some of the sensors are cameras. This is a 360-degree lens
that was done
that we prototyped on there by cutting the model out of acrylic. We also cut the model out of aluminum just for fun. Not that you would use an aluminum lens.
I don't. That would be.
But it gives you a feel for what the shape of that model would be like.
The smoothness and perfection actually is amazing.
It is impressive. And then an example that came off of the rubber plastic printer is a bunch of buttons with different hardnesses of rubber. So you can decide, even before you manufacture this thing, what do you want the buttons to feel like?
So you get all these and then you say, I'll go with that one.
I'll go with that one, and I want the buttons to have that much hardness or that much give, right? And they have a newer version of that printer now that, in addition to rubber for the sole and hard plastic for the upper, can print colors.
Wow!
And so now not only can you have different hardnesses of rubber, but you have different colors. With the right size, you could just print your tennis shoes.
So this is my future shoe is here, right?
Yep. Well, think about the customization possibilities if you're printing it for yourself.
I see.
Not only could have your own pattern or your own design, but it will actually fit. You could scan your foot and make sure that the shoe actually molds to your foot. And decide how much rubber you want under the sole, under the toes.
So a lot of this can allow a lot of individualization.
Mass customization, they often call it.
Mass customization.
So you have some basic idea, and then you just make it perfect for you. Actually, the 3D metal printers are being used for that today, in that one of the biggest uses of titanium is in healthcare. They use hip implants or dental implants because the titanium isn't reactive to the human body. And so you need a particular tooth implant. They're going to have to design it for you.
Customized.
You don't want to wait for that.
You have a mass idea and you customize it to a patient.
You just adjust it to fit for that patient. Same kind of with hip joints. All the hip joints are a little bit different to be the right size and actually work. But the big idea is all the same.
Wow.
Similarly, we have another manufacturing tool here, which is actually a large format mechanical cutter. So once again, a vacuum table. And then we could put cardboard or we could put textiles here.
Vacuum table means
it just holds it in place. And then we can cut a pattern reproducibly, right? So some of our companies make wearables, and so they need to cut textiles or fabrics. They can do it. This pattern can be cut over and over again, reproducibly. We also use it for making packages for consumer electronics products. So you want to prototype, what does the box look like that comes in? Do all the pieces fit? How do you hold them so they don't move around in shipping?
Very important,
And so we can do that here very quickly and make sure that everything works well before it goes to the factory. And once, the whole idea for a startup is to save time and money. Right? And so if they can, get through the process quicker, they can get to market before their competitors, and they can spend less money, which makes them more efficient. And then this is one of our other exciting tools. It came a little later in Playground's history, which is called a 5-axis mill.
5-axis.
And so it can change the thing that holds the stock product. So here it is, it's spinning it, as well as it can move the cutting tool in 3 dimensions. So the cutting tool moves in 3 dimensions. The holder moves in 2 other dimensions.
Wow.
And that allows it to make a 5-axis cut. Quite impressive. So they're using a jet of air to hit some fins around the outside of that window. And it's spinning on its central axis.
So a jet of air comes there. This is spinning all the time. That's why
really
it's clean
fast,
and okay.
so nothing sticks to it. It turns out they actually use this in marine applications for the captain of a boat. In a storm, you can't wait for the windshield washer to come back and see if there's something in front of you.
Wow.
And so they spin the window and keep it clean. And so you'll see over here that this has a large number of different tools that can change to do different fine detail. So like for this one will cut a large flat surface, but then this little needle-nosed one will cut a little tiny hole in it.
The precision of it is so impressive.
This one is a real robot, right? It can do anything. And it can do it in a production cycle where you just put in the raw materials and tell it to go do that, right? Because it's running a program, and it can change the tools and change the holder, right? And change the position, and it's just executing that program.
Fantastic.
And it's actually incredibly powerful. It can cut ceramic, it can cut titanium, you know, cut iron, cut stainless steel. So from a prototyping point of view, or even a little bit of a production point of view, you can pretty much make anything.
Yeah, you can already see it's done quite a huge amount.
Yeah. This is used in aerospace to make rotor blades for a turbofan.
Okay.
Or a jet engine.
Where you need precision. And
wow. And you're cutting it out of titanium or something, like that.
Yeah.
Some of our other 3D printers, this one can do very thin wall thicknesses, so very fine features. Very precision products where you want to have you know, geometry that has very fine detail that you want to be able to manufacture. But you need to be able to prove that the design is correct before you make, you know, thousands or millions of them. This one, on the other hand, can print in a very large format.
I see.
And so, for example, you can print an entire motorcycle helmet in one print.
Wow.
Just because it's big enough.
So you can create a motorcycle helmet here.
And then finally, this one can do a clear polymer. And then these are actually some of our testing chambers. So for environmental testing, to see how these products last over time. We can cycle the temperature from very hot to very cold to very hot to very cold to see if they can survive outside. And we can cycle the humidity. So you can make it really hot and humid. You can make it really cold and dry.
So you put a product there and see how it survives.
In there, you see how long it takes before it starts to break down.
Amazing.
Step in here in our reliability lab.
It's called the reliability lab.
Yeah, so basically it's a test lab, right? And so, for example, these are some more of those environmental chambers.
Yeah.
And you know what they're doing here is they've got products that they want to actually have sensors connected to as you're heating it and cooling it. You want to see if it still works.
Yeah.
Right? So you're not just brakes, but does it work? At what temperature does it stop working?
Very important for India, where we have 47 degrees centigrade.
And also just humidity, right?
Humidity, exactly.
How long can it last at what humidity? And so that's important here. This is one of the favorite testing machines. It's called a drop tester. And so these little suction cups can hold a product at a very precise angle. And then you can put it at a precise, at 1 meter, 2 meters, and then you drop it onto granite.
Oh gosh, I'm not trying my phone on this.
And actually, we've done a lot of phones on this.
I can imagine.
And you can drop it on the bottom, on the corner, on the side, on the back, on the front.
All these suctions, you can hold the angle.
And you can repeat it. And then the amazing thing is then you have some very bright lights and a very high-speed camera here. So this camera can go up to 1 million frames per second.
What?
And so the goal is to see how this performs
in slow motion.
In slow motion, right? Oh, there he comes.
Okay,
so basically, you see that shock wave that runs up through it as the thing falls apart. So the interesting thing about this high speed is that you know that maybe the battery door always comes off of the thing when you drop it, but it's not necessarily the battery door's fault, right? It could be something higher up that gave away first, that then created this cascade that allowed the battery door to fall off.
You can see the kind of very minute.
Exactly, and so I think this guy is running. You see, this guy's at very high speed, so he just bounced.
Okay.
And he's barely moving that way.
Wow. Million frames a second.
And so, it's quite fun.
Not bad, not bad.
And then this is another tester. This is called an Instron. And what it can do is it can put very precise amounts of force, either pushing or pulling. And it can do that repeatedly forever, right? Okay. And so, you can decide, by pulling on this thing, when's it going to break? Or by pulling on it 100 times, just this much will it break. Or 1,000 times, just this much will it break. Or pushing on it this many times, this much, right? Wow. And super repeatable. And so you know exactly from a calibration point of view what the stress levels were and what would it take to make it break.
Fabulous, fabulous.
And then finally, we also have, to see the metal floor here is a little funny. But this is for, one of the things you have to do with consumer products and a lot of electro products is you have to test them against shock. Electrostatic shock.
Yes,
so you walk up to it and you shock it. Is it going to break? And so basically, this allows you to repeatedly shock something at different levels of voltage and static electricity in order to see where it fails and why it fails.
Okay. Okay.
Also, we can't have enough robots. You're like, why would we have a robot in a reliability test lab?
Yeah.
Well, it turns out that these days, a lot of products have gyroscopes and they have accelerometers. And if you want to test something with accelerometers, you have to run it through acceleration.
Yeah.
Well, robotic arms are really good at creating acceleration forces and testing and calibrating whether it's actually reading accurately. And how long can you do that until it stops performing? Wow. So that robotic arm gets a lot of use. And you ask about learning. You see there's a little, actually, vacuum pump over there and a little bit of water. One of our companies created a product. It's actually the product that's bouncing over there in the white product that's bouncing on the screen.
Yeah.
And what it is a pool sensor. Here's actually some over here. And it's a, let's get one with a sensor in it. Yeah. So it's a pool sensor that keeps track of your water chemistry. And so it can know what your chlorine levels are, what your pH levels are, so you don't actually have to go dip a strip and check the color and decide how that all works. It just knows and reports it up to the cloud. You look at your little phone app, and it tells you, go put in 2 blue pods and 1 green pod in order to make your hot tub safe. And so one of the things we learned, so here's the case and the sensor, and actually there's a trick to taking this apart, which is really just pull on it.
Wow.
You think I broke it.
I thought, I got worried.
It just pops apart. So this is the sensor that floats in your pool. That's just the casing.
Okay.
And it's got an antenna that has to be able to communicate back up to the internet. It's got a little battery and a little bit of electronics that talk to the sensor that floats in the water.
I see.
And this whole thing floats. The thing we learned here was that while this plastic is waterproof, like almost all plastics are waterproof,
yes.
What it is not is water vapor proof.
Oh,
and water vapor is actually a very small molecule. And normally that's not a problem because the amount of water vapor outside of this and inside of this will equalize, and then you're done.
Okay.
And so having a little bit of humidity here and a little bit of humidity there, not a big deal.
Right.
And if you got too much humidity inside, it would actually work its way out because it wants the concentration to be even, right?
Right.
The problem is that if you put this into a cold pool and it's floating, the bottom of this is cold.
And that's hot, yeah.
And
maybe
the outside air is warm. And so you'll get humidity that goes in, and then it condenses because it's cold. And then when you condense the liquid out of the air, then that air becomes dry, and more humidity goes in.
So it
just keeps going, and eventually this fills up with water.
Wow.
And it sinks, and then the electronics stop working.
Yeah. So how did you crack it?
Well, it took a long time to figure out exactly what was happening because no one could believe that where all that water was coming from.
Right.
And initially what we did is we put some desiccant in here. Whenever you get an electronics product, sometimes you get desiccant with it.
Right.
A little packet of white powder.
Yes.
And that sucks up moisture.
Yes.
So we said, well, there's moisture getting in there. We'll just put desiccant in there.
Right.
And what happened is that dried out the air inside, which sucked in more moisture.
Right.
And so it'd fill up faster if you put desiccant in it.
My God.
And we're like, well, okay, that's interesting. So basically, what we ended up doing for this product, there actually are plastics that are completely impervious to water vapor. What we ended up doing for this product, you can see it right here, is this thing is the electronics are completely coated in epoxy.
Oh.
So it doesn't matter if they get wet.
Because it doesn't go next step.
Because it won't get affected by the water.
So even a product like this got
so simple.
Quite a lot of thinking. Yeah, so simple, right? Thank God I'm not designing.
Well, it shows you that none of the 4 founders at WebTV had ever made a pool product before, because we had never made those mistakes before.
But what you know is that there will always be a surprise and a mistake. Yeah.
Of course, you have to learn.
You can't imagine that.
You're not alive if you're not learning.
Exactly. Yeah, I love that.
And so we have portfolio companies here, of course, and we have our electronics lab, which we get the privilege of having some of the electronics equipment that most startups would just dream of, right? Very high speed oscilloscopes, or whether it's network analyzers that can look at frequency spectrums and do RF testing. Maybe they would rent something like that, but we just have it available because across dozens of startups, it makes perfect sense just to have it here. Saves time, saves money.
Wow.
And then of course we have technicians.
So you would have invested in all this?
Absolutely.
Yeah.
And
everybody, all the
companies
gets to use it. Lovely, lovely.
And then of course we have technicians that help with that with that process. You always need meeting rooms of various forms and sizes.
No, I do want to explain that something you explained last time, that these are completely soundproof.
They are.
Completely soundproof.
Yeah, we can go in one of the smaller ones. They're super popular.
Yeah.
Because in these open environments where you want to work, because you want to know everything that's going on with everybody else in the company, because that's the type of super high bandwidth communication that allows these companies to move so quickly, right?
Yeah,
They're not writing reports and sending status updates, right? They can just hear what the other people are working on, and if something's doesn't correlate with what they think it should be, they just tell them. Right? And that's the great thing about a small company, is it moves so fast.
Beautiful.
But the downside of being able to hear everybody's conversation is that sometimes when you have to think, or when you have to have a one-on-one meeting where you have to have maybe a performance review or a hard conversation, you need some quiet space.
Yes.
And you don't want to have to go very far. So we'll come right back to that. But the other thing that you need, besides quiet space, is you need caffeine.
Another food again.
So this is the 24-hour version of when the cafe's not serving breakfast, lunch, or dinner, right? So we have the manual transmission caffeine.
Okay.
We have the automatic transmission.
I did have coffee from this. Very good.
It is, and it actually has an innovation, which is a refrigerator for the milk.
Yes.
And so the milk stays good 24/7. And you can still have your cappuccino or latte without thinking very hard and still focus.
And you don't have to do all those things.
On the problem. It's funny though, because some people really like moving the knobs.
The analog feeling.
Yes, and doing the stick shift.
But actually this does exactly the same thing.
Fabulous job here.
Yeah.
And it has two choices, because you have the espresso and the coffee beans, and you can choose between the two just by the push of a button.
It moisturizes it or something.
And it runs Android, of course.
Of course.
But in addition to caffeine, of course, you have salt and sugar. Right, so you have all the food groups in one place.
Okay. My God, you got your priorities sorted out. Food must be right on top there, right?
It is the engineers don't think very much beyond what they're working on, and a empty stomach, is very distracting. In our meetup lab, yes. So unfortunately, we won't be able to go in there, but this is a great space for bringing in outside speakers to talk about how to recruit talent, how to incorporate your company, how to ship products,
or lead a team, or
lead a team, management 101.
startups go in here and listen. And
yeah, and then often they have their company meetings here as well. This is going on right now. One of our companies actually who's graduated has come back to use this as for an offsite for the day.
Okay. When you say graduated, means what?
Means they're no longer physically in our facility. They've gotten too big. They're moved on.
But they're still completely part of.
They're still part of our family.
Yeah.
We love all our kids, of course.
Yeah. Right.
So yes, we can try hopping in here, get a little feel for the quiet. Can even bring a camera in if you want.
We can go in here and the audio.
That's true.
That's
quite exciting. They can still hear us, maybe.
They can hear us. We can't hear them. Yeah. Shout. Shout.
No.
Speak up.
Anyway, so they're great for video conferences.
Oh, okay,
they're great for one-on-one meetings.
Oh, and you know, just bring it in.
And then you can see over there they have different formats across the hall here. You have one that just has a desk, so someone can go and get some quiet time, focus on getting his homework done that he didn't get done last night.
One person, 2 people, 4 people. Yeah. Brilliant.
But yeah, active ventilation. A little motion sensor that knows we're in here, so it's just blowing some air through to keep it fresh, so we don't fall asleep, and turning the light on.
Lovely.
Did you see Iron Man last time you were here?
Actually, earlier today I stood with him.
Yeah.
It's from waste material or something, right?
It is. It's from Thailand. It's actually from parts from I think.
Man.
There's some motorbikes in here and some other pieces. My favorite part is the Nest thermostat. Unfortunately, the battery has died on the Nest thermostat. But
what is it?
It's a Nest thermostat.
Okay, Nest,
and so I don't know if you ever watched Iron Man, but it used to be that when it got cold in here, the Nest thermostat would turn on and his eyes would light up red.
Okay.
And he was powered by the Nest thermostat, which was quite exciting.
Lovely, my God.
A few video games.
That's my generation. Yeah. Those things can be very addictive, I don't know if you've ever been through a period of...
It's that whole, personality, addiction. Yeah.
College days, addicted to table football.
I had an Apple II in college days, and we had a pile of video games. And one of my roommates was so addicted to the Apple II that he almost flunked out of Stanford. Because he spent all his time playing video games instead of doing his homework and studying.
Really can happen. Hopefully he's done very well after that.
This is one of our audio test labs. And so, in this day and age where microphones are so important, the ability to, hear people, for robots to hear people from a distance, we need a sound environment for testing microphones, also testing speakers, make sure the audio reproduction is of best quality.
Amazing. And one of the best photographs I've ever taken of me on $1 million bike.
Yeah?
Last time.
That sounds great.
These are all from different movies or something, right?
They are. Let's go take a look. So we use them as design inspiration, just in that,
The beautiful designs, actually.
It goes to show that, look, these are all motorcycles, but they all have different personalities, and they have different attractions and different strengths and weaknesses, and that, they're all custom made, but it just shows all the variation of what's possible in something as simple as two-wheel transportation.
They're so different, the personalities, each one.
My favorite is the one with the visual gas gauge.
Okay.
So you know how much gas you have because you can see it.
Just come and have a look at this. This is the amount of petrol you have.
And you can also see whether your air filter needs changing. Because you can see your air filter, right?
You don't have to open up, take it out, just see it.
And then finally, if you look over here, when you open the throttle, you can actually see the carburetor open up here. Go ahead and give it a spin.
Wow. That is so...
And you can see this was being ridden recently because there's some oil splatter up there on the window. But yeah, so this one, let's see if I can get this correct. So I know this one was in The Accountant.
The Accountant, the movie, yeah.
And it actually looks like the seat wouldn't be comfortable. It actually is quite good. Maybe you should try this one.
Okay, I'm not trying.
It has a little bit of a spring to it because it's hanging out there so far. You can straighten it up. Yeah, here, straighten these guys out.
Oh, yeah. I never had a motorbike as a kid, so this is a
And this one, let's see. This one I believe was in Transformers.
Transformers, okay.
And then this one was in The Fate and the Furious, so one of the Fast and the Furious movies.
Oh, right. Wow. Just lovely to have these. As you say, as design.
It just shows that, you know, and then we have a fifth one over here, that, you know, you have to think about who your product is for and how to make it approachable and attractive and compelling, and also certainly useful. Right. I mean, once again, they decided
similar to that one,
the gas tank is a good one. But you know, different kind of shock absorber headlight option, funny different wheels, and you know, more of a saddle. Although I love the practicality of they took the leather and they wrapped it around here to make sure
you never get the heat.
You don't get the heat from the engine.
Wow.
I mean, probably scooters would be better, more appropriate for the playground. But these are quite exciting, just the same.
It's a bit of history, so you've got to have that as well.
And I don't know if you got we mentioned earlier about the tree, in that the tree in the playground, actually, we had someone from Missouri come in and build the tree. They actually brought a big chunk of it with them. It was the same company that actually built some of the trees in New Zealand for Lord of the Rings. But these were originally two separate buildings.
This is a built tree, can you imagine?
These were originally two separate buildings, and you can see where we've cut out the hole between the two buildings. And then there's a post hiding underneath the tree that holds up the the center.
Whole thing,
and then we put the steel across the top. But originally these buildings were built in the 50s to be actually a cannery, a tomato cannery.
Really?
We actually talked to somebody who worked in one of them, heard their mom had worked in the tomato cannery that was here. And there was a railroad track run through the parking lot to bring the tomatoes in and then to take them to market. And so to think of Silicon Valley, you know, they often hear about it as being an apricot valley, and there still are some apricot trees around.
So,
but just imagine
you did
Silicon
all this.
Valley.
So are you a secret architect as well?
No, we certainly had help, professional help.
I bet you took a lot of that.
But it needed a lot of work. This building over here didn't look much like this when we got it about a couple years ago. There were holes in the ceiling. They weren't exactly skylights. They were just rain coming in. And there was no heating or cooling, not enough power. Some of the floor had to be demolished and reconstituted.
But I love the kind of natural cement.
Everything we could keep, we just polished.
Oh, this is original?
This is original. You can actually see some of the some of the trolley marks they had on top of the tree. And when we polished, not all the yellow paint lines came off, but it's kind of like an archaeological dig. You can see what's underneath it all.
That's original?
The posts are all original.
Wow, it just makes such a difference. And then we took our playground red signature color and painted up the fire pipelines. All these things go somewhere subliminally. The guys here may not be absolutely conscious of it, but it makes a difference somewhere, doesn't it?
One thing we did that I think made a big difference was the ceiling was all painted white with old lead paint. And we made the decision, and we almost regretted it, to have it all sandblasted back to wood. And the reason why we almost regretted it was that it took almost a month to, they said they could do it in 2 weeks, and it took more than a month to sandblast it, because they had to since it was lead paint, they had to put on suits. And so it kind of looked like Beijing in here, because you couldn't see anything. It was just powder everywhere and low visibility.
Do you still feel this is healthier?
Oh, absolutely. And I think it has this much more organic, much more attractive feel to it.
Natural light coming in.
And then we put in more skylights. We put in all the HVAC units. One of the crazy things about putting in the cooling units on the roof is the architects calculated that it was cheaper to put in 40 small ones than one big one. But it was going to take them several days to lift 40 units onto the roof, and they had to close the surroundings, and some of these other offices couldn't be used while they were lifting all these things high up onto the roof. And then one of the engineers came up with, we don't actually have to do it all with forklifts and cranes. we could do it with a helicopter. And in fact, so they were able to, one morning, starting at 8 o'clock, they had 40 HVAC units parked in the parking lot, just on the ground. And they had a helicopter operator come in, and in 39 minutes, less than 1 minute per unit, they had lifted each one up and set it on its pad and turned around and gotten the next. And so in 40 minutes, they had moved all 40 units, and the helicopter went back to where it came from.
Sort of a crane.
It was like a
long arm.
Yeah, it was like a dance choreography move, right? I mean, because he had to look out the window to see where he was, and he had to fly and set it down, and then keep turning and come back and get the other one, and then come back up.
And it was 39 minutes all done.
Endless.
Unbelievable.
It was amazing.
Wow. What a brilliant idea.
And I would never even have thought of it.
Yep.
And now I'm like, of course use a helicopter. Why not?
Who wouldn't have thought of it? Yeah, simple.
Now, if only that helicopter could fly itself. Maybe not.
Well, these flying taxis and things coming, I don't know, but wonderful, 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 inspiring. God bless you, Bruce. You've been really great talking to you.
Thank you.
I can feel the energy, and I just hope 1 millionth gets transferred.
Certainly our privilege to have the conversation, and love to have you back anytime.
Lovely. Thank you so much. Thank you so much.
Thank you.
The remarkable Bruce Leak. You cannot find a more brilliant mind and a more humble soul than Bruce. In fact, one of the common themes in the playground, they may be billionaires, they may be hugely successful, they may be at the pinnacle of Silicon Valley, but they're all also amazingly humble. I sense that humility defines the character of Playground. In fact, I would go so far as to say, while the entire Silicon Valley has a high density of billionaires, and everyone is changing the world, and it's being done with remarkable humility, which is also what makes it a very special place in our world. Well, that's it for this episode. Next week, we meet many of the actual young geniuses that Playground is helping. And we take a look at the crazy products and the crazy new world each one is trying to create. A real ground level glimpse of the future. That's coming up next week. Don't miss it.